Hey everyone, welcome back to PRV Tech Creations. Today we are making a DIY touch wall switch that will not only enhance the aesthetic of your home but also bring it up to date with your modern technology. First up, let's talk about the touch sensor. Instead of going with a commercial module, I built my own touch sensor, giving me a complete control over customization. For this, I used the TTP223 touch sensor IC, the same one found in many commercial modules. The IC is a capacitive touch sensor that detects the changes in electrical capacitance. When a conductive object like your finger comes close to the sensor area, the IC detects the changes and switches the output signal. My homemade PCB for this sensor is designed according to the IC datasheet, creating an outline ground connection path to narrow the sensing area and make it more precise. Pin number 3 is connected to the sensor pad using a thin copper wire. Pin number 4 and 6 are used to select the output mode. In my case, I left pin number 6 and connect pin number 4 to high to choose direct and active low output mode. Mounting a WS2812B addressable LED through the PCB drill hole provides a cool visual feedback. Thanks to the super glue, we can strongly bind the LEDs in perfect position. The beauty of this addressable LED is that we can control the color of multiple cascaded LEDs using a single data input. Thin copper wires help make the necessary connection paths to the LED and sensor board. This is a meticulous and patient job. Finally, I applied the black lacquer coat to prevent the board from corrosion. It not only enhances durability but also the final appearance of the touch module. I designed a double-sided PCB for the main control board to give a perfect finish to this project. And it is helped to connect and solder the component very accurately. The microcontroller I am using is Atmega88, the brain of the circuit. It will control the entire switch behavior as we program it. Meanwhile, for those who haven't subscribed my channel yet, you can hit this button while I am soldering this. Now you might be wondering how we can control high voltages with 5V microcontroller. That's where a relay comes in. It acts as a switch to control high voltage appliances. When a relay is activated, it allows current to flow through its normal open contacts, powering the connected devices. But instead of using electromagnetic relay, I'm opting for a triac circuit, which is commercially available as a single module known as a solid state relay or SSR. In this project, I am using the BT137 triac, which can be handle AC current up to 8 amp. That's more than enough for my needs. But to control it via a microcontroller, we need a triac driver. The MOC3043 triac driver is perfect for this purpose. It can be directly connected to the microcontroller pin via a series resistor. The internal optocoupler of this driver provides excellent isolation between the low voltage circuit and the high voltage AC side. Although I designed the PCB to accommodate 7 triacs, for this project I am only using 2 of them to control 2 lights. Additionally, I have attached a small buzzer speaker with a proper transistor driver circuit to give a feedback tone when the output state changes, which is a nice touch. And for future upgrades, I have added my favorite 2.4 GHz RF module, the NRF24L01. It is connected to the microcontroller via its SPI interface, enabling seamless wireless communication for even more project possibilities. This customized USB nano connector is used to connect microcontroller to the USB programmer effortlessly. To connect the touch sensor panel to this main controller board, a JST connector is used. It allows us to connect or disconnect the front panel very conveniently. The thick wires are soldered for the main AC voltages. Having such wires is very good to reduce the resistance of the AC voltage side. This circuit needs 5V DC power supply, so I chose a 5V switch mode power supply. Since this is a 10V unit, it can be delivered up to 2A current, which is more than enough for this circuit. The front panel of the switch is made by using a PVC sheet. Cutting it to a perfect rectangular shape requires a good practice and patience. After the cutting process, smoothing the edges of the sheet using sandpaper not only helps the improved quality but also the final appearance as well. I drilled 2 holes on the horizontal center line of the panel for the touch sensors. I used PVC casing part for the frame. Carefully and straightfully cutting the casing part is essential. Then bind this part to the front panel. A little bit of sanding and cleaning will give a perfect bind with the help of super glue. This should be done patiently to keep the straightness and perfect rectangular shape, which is directly affected the final finish and quality. My purpose is to install the panel onto the existing switch as an outer cover. Keeping the exact rectangular shape and seamless joint on the corners are key points for the final appearance. If you have a 3D printer, this task becomes much easier and more precise. Now it's time to think about the painting. Because my walls are white, painting this front panel with a matte black gives a marvelous appearance to the switch. Thanks to spray painting, we can get a nice and perfect look for the panel. After painting, I attach touch sensors to the front panel using hot glue. And I use some hot glue for the drill hole as well, which is perfectly help to diffuse the light coming from the LEDs. After that, we can solder the connector wires to the sensor module. We should be very careful to solder these JST connector wires accurately. Hot glue will secure the connector wire from losing. Now let's move on to the coding part. We will write a program that reads the touch sensor's input and toggles the output accordingly. Here's the code we will be using. It's quite straightforward and easy to understand. You can download the code and schematic from my Patreon page. The link is in the description. Upload the code to the microcontroller and we are almost ready to install everything. With our circuit ready, it's time to install the switch into the wall. Make sure to turn off the power supply before working with high voltage wires. After all wires are connected to the circuit, a according to our wiring diagram. It's time to turn the power back on and test our touch switch. Perfect! It works beautifully. If you encounter any issue, double check your connections and the code. And there you have it. A sleek, modern touch wall switch that adds a touch of sophistication to your home. It's a simple yet effective upgrade that you can proud of. If you enjoyed this project, give us a thumbs up and don't forget to subscribe my channel. Leave your questions and project ideas in the comments below. Thanks for watching, and as always, stay creative.